Hello there, y'all. We are today going to look at surface area, okay? And surface area is basically the area of all the surfaces of a 3D figure. Right here I have a triangular prism drawn, okay? And it's called a triangular prism because we can see two of the sides of it, two of the faces, are triangles. Okay, and prisms are named after their bases. Okay, and so basically whatever kind of shape one of the bases is, that's the name of the prism. And since we have two sides here that are triangles, like those are the different ones, this is a triangular prism. Okay, there's always two bases on a prism. So whatever shape you have two of, that's going to be your bases, and whatever shape they are, that's how you name it. So since we have triangles, this is a triangular prism. Okay, there's two things though that we have to know about surface area. There is total surface area, which is sometimes just called the surface area. Okay, and then there is the lateral. Okay, and so lateral is just going to be the sides only, no bases. Okay, so if I was going to find on this triangular prism here, if I was going to find the total surface area, I would have to find the area of the two triangles here, and then I'd also have to find the area of these three rectangles here. There's one in blue. Okay, here's the one that's sitting on the bottom there in green. And then also this one in pink. So I'd have to find the area of those three rectangles plus the two triangles. Okay, and that would be the total surface area because there are 1, 2, 3, 4, 5 total faces on this prism. Okay, so total surface area is all of the faces. Okay, all the flat surfaces, the area of it. Now, if I was just going to do lateral, okay, lateral only, and let me actually draw what we're calling, what we call a net here, okay. So basically I'm just taking this triangular prism and flattening it out. Imagine it's like a box, you know, you can flatten it out here. If I'm just going to do the lateral surface area, that means I only want the sides and no bases. Okay, remember, a prism is named for its bases. So if I want the lateral, I only want the side, no bases. If we're dealing with a triangular prism, I would not want the area of the two triangles. If I want the lateral surface area for a triangular prism, I would only want these three rectangles. Okay, so I just want you to understand the difference between total surface area and lateral surface area. Total would be all 5 sides of it. Lateral would only be these 3 rectangles that are wrapping around the sides of it. Okay, so that's kind of the idea of total and lateral surface area. Now, in order to do this, we're going to use our formula chart here. You can see we have all of the formulas for the different kinds of shapes that we're going to use. We have the lateral surface area formula and then the total surface area formula. So you have to look and see, okay, what is my question asking for? Is it asking for the lateral or is it asking for the total? And then you look up the formula according to which one you need. So for a prism, pyramid, okay, for prisms and pyramids, you'll notice we have these letters here, capital P, okay? Capital P is the perimeter of the base. Okay, so if we went back to our triangular prism up top, it would be the perimeter of that triangle, okay? So capital P is perimeter of the base. H is height, okay? And your height is the distance between the two bases. And then So that's for prisms. Okay, so perimeter and height. Now I'll go over here and look at total, because I'm going to look at these letters over here as well. So we talked about capital P, we talked about H. Now here we have capital B, okay, big B as we call it sometimes. Capital B stands for area of the base. Okay, so it's important that you understand capital P stands for perimeter of the base and capital B stands for area of the base. And depending upon what shape your base is, you're going to have to use a different formula. And we're going to talk about that when we get to each kind. So again, I'm making this video and it goes along with the kinds of questions you're going to have in the practices, and then it also goes along with the kinds of questions you're going to have in the quiz. So as long as you reference these notes while you're doing the quiz, you will be just fine. Okay? So H is height, P is perimeter of the base, big B is area of the base. So that's for prisms. I'm going to start with prisms right now. And then we're going to come back up here for pyramids, cylinders, cones, and spheres. Okay, so next page. First thing we have here is a rectangular prism and a triangular prism. Okay, I know that they're prisms because I can see they have sides that look like rectangles, and then there's two other sides that look the same to each other. So like here on problem number 2, I can see that there's two triangles. So these are my bases. And sometimes, like for example, on the rectangular prism, any one of these could be your base, because for a rectangular prism, they're all rectangles, so any of these sides could be bases. So sometimes they will specify for you on a problem that have one side shaded in, and that will be the base. So on number 1 right here, I'm going to shade in this back side, and I'm going to say that that is my base. So then I say, oh, okay, which one matches it? Well, it's the one across right here. So these two would be my bases. Okay? So looking at these prisms, we need to find the perimeter of the base, the area of the base, and the height of the prism. You always want to start off with those, okay? Because we're going to be finding the lateral area and the surface area. So we need the lateral and the total. So remember, surface area means total. All right, first thing, perimeter of the base. Let's look at number 1. This is a rectangular prism because all the sides are rectangles. Okay, they've told us that these two ends are going to be our bases. So perimeter is just adding up all the sides. So here I can see this one on the end. It's got two sides that are going to be 8 and two sides that are going to be 6. So I'm going to do 8 plus 6 plus 8 plus 6. All I did was go around to the 4 sides. Okay? Because remember, if you have a rectangle, you have two sides that are the same for each kind. So go through and you add those up. So 8 plus 6 plus 8 plus 6, and you will get 28. Alright, that's the perimeter of the base. Now area of the base. Okay, remember it's a rectangle. So your base is a rectangle. So to find the area of it, it's going to be base times height. And this is just, I'm only concentrating on the base, okay? This h right here is not the same as this h in this other formula here. I just need to know, how do I find the area of a rectangle? Base times height, well, what are the two sides of a rectangle? 6 and 8. So 8 times 6, okay? So 8 times 6. So whenever you're doing rectangles, for your perimeter and your base, you should be using the same two numbers, okay? You see how for perimeter I only used 8 and 6. For area of that one, I only used 8 and 6. So 8 times 6, that's 48. So now I have that. Okay, and then now the height of the prism. The height of the prism is the distance between the two bases. So right here, you see I can draw this line from the back base to the front base. That would be my height. Okay, and right there it is 11. All right. This height is the distance between bases. So basically, how far apart are your two bases? So there's that. So now, let's hop back to our formulas here. Okay, and we're dealing with a prism. Okay, prism. So the lateral is going to be, and they use S for lateral. Okay, S is for surface area. I'm sorry, not lateral. Okay, surface area, and then since it's classified under lateral, all right, we have perimeter of the base times the height of the prism. Okay, so let's remember that. Lateral is P times H. Okay, and then total, let's hop back there. Okay, total is P times H plus 2 times B. So P times H plus 2 times big B. Okay, and think about it. On this prism here, okay, we have the 4 sides, all right, because it's a rectangle. There's 4 sides to it. So we have these 4 rectangles like this, okay, those 4 ones. But then we also have the 2 that I have highlighted in pink. So we have to have the area of all 4 of these on the sides plus the 2 on the ends. So the P is the perimeter, okay, because if you added up all of these rectangles that are going along the sides, they would all have, basically, like if you unraveled it, it would be the length of the perimeter of the base, okay? And then they're H long. And then 2 B's because there's 2 bases. All right, so all we do is plug in. We figured out the perimeter of the base, which is 28. We know the height of the prism, which is 11. So just do 28 times 11. So you get 308, okay? And that would be, that would be in centimeters squared. Okay? Now we go for total. Okay, total. Again, it's P times H, so 28 times 11 plus, and then now we have to do 2 times B, so 2 times, and then big B we figured out was 48. So plus 2 times 48. So you get 404. Okay? And that's, again, centimeters squared. But just on the quiz, all you need to do is type in the numbers. Okay, so there's your lateral and your total. And you have to be careful on the lateral ones. If the base is not specified for you, you might come up with a different number on the lateral. So like, for example, let's say on here, I had used one of these green rectangles, like the one on the top. If I use that as my base, you know, then my lateral surface area would be different. But we will always specify, like on rectangular prisms, that's the only one where it will like change. On rectangular prisms, we'll always specify the base for you, so you can make sure that you get the correct lateral surface area. All right, question 2. Now, this is a triangular prism. And again, it's a prism because I see 2 shapes that look the same and all the other sides are rectangles. So for my lateral, if I'm doing the lateral surface area, there's 3 rectangles here. There's these 2 that are like slanting and they meet up here at the top, and then there's the one that's on the bottom. Okay, so those would be for my lateral surface area. So now my base is the triangle because it is a triangular prism. So now what I will do is figure out the perimeter of the base because it's a prism. Okay, you always go back and say, okay, surface area for a prism, I need P times H plus 2B. So those are the things I have to know. I have to know the perimeter of the base, the height of the prism, and the area of the base. So always for prisms. So perimeter of the base. So again, our base here is this triangle. And y'all, a triangle has 3 sides. So when you're finding the perimeter, you should be adding up 3 sides. So we have a 4, and then the other side is 3, and then the slanted side here, I get it from the other one here, it's 5. So 4 plus 3 is 7, 7 plus 5, that's 12. So the perimeter of my base is 12. Now I need to know the area of the base. Again, y'all, look right here. You see this right angle? We also got the right angle there. This is how your triangle looks. Okay? For the area of a triangle, it's base times height divided by 2. And this is only coming from the triangle. So remember, your base and height are at a right angle. So we have 3 times 4 divided by 2. So 3 times 4 is 12, divided by 2, that's 6. So the area of these triangles is 6. And now the last thing we need is the height of the prism. The height of the prism is the distance between the two bases. So y'all, how far apart are these two rectangles? Okay, all of those could be heights. We have this one up here labeled. So the height of our prism is 4. So now we just will plug into our formulas. Lateral, if you go back to your formula chart, it's the perimeter of the base times the height of the prism. And then total, it's the perimeter of the base times the height of the prism plus 2 times the area of the base. So P is 12. The height of the prism is 4. So 12 times 4 is 48. And be inches squared. Okay, and then now total, again, we have P times H, so 12 times 4 plus, and then 2, and then the area of the base, so the area of these triangles we figured out was 6. So we have 48 plus 12, so it's 60. Okay, and that would be the total surface area. Okay, next thing we'll go on to here is shape number 3. This is a pyramid, okay? And more specifically, it is a square pyramid, because if you look at the bottom, okay, the base for a pyramid is very easy to find. It's the bottom part right here, the side opposite from where the point is, okay? So if you see the point, go to the other end, that's your base. It's a square pyramid. So let's go back to our formula chart and let's see what we need. So for a pyramid, okay, the surface area is 1/2 capital P times this L character here. Okay, what is this L character? Well, L is the slant height. Okay, the slant height. And if when we go back to our picture, you'll see it's how long the slanted side of something is. Okay, that's our slant height. So that's for the lateral, so that would be only the sides of it, the triangular faces. And then here, to find the total, well, we have to do the area of all the triangles together plus the area of whatever the base is. Okay, so that's why we have just a one big B. So if we look here, all right, we have 4 sides, and we're only doing square pyramids, so you don't have to worry about that, okay? We just have these 4 sides of the base, so we would need the area of the base there, and then each side of the base has a triangle coming up off of it, you can see. So basically we're doing 4 triangles plus that one square that's at the bottom. Okay, that's the total surface area. Now slant height. You see this right here? This line going up the center of that triangle? That is your slant height. This is L. So again, for the surface area for a pyramid, a square pyramid, we need the perimeter of the base, we need the area of the base, and we need the slant height. We already know the slant height from the diagram. It's 12.5. Now, perimeter. Okay, it's a square, y'all. So there's 4 sides here. They're all 7 in this picture. So 7 plus 7 plus 7 plus 7. Could we do 7 times 4? Yes. Okay, so the perimeter of our base is 28. Now area of the base. Again, it is a square, so we will do base times height. But they're both the same, so 7 times 7, so it's 49. So surface area. Lateral. Okay, lateral surface area is going to be 1/2 the perimeter of the base times the slant height. So 1/2 times, and the perimeter of our base is 28, and times our slant height, which was 12.5. So just type this in. Okay, and remember 1/2 is 0.5, so 0.5 times 28 times 12.5, and you will get 175 meters squared. And that's the lateral. Okay, and by the lateral, let me shade that in really quick. By the lateral, I'm meaning just these 4 triangular faces here. So all these sides that are pointing up. Okay, that would be the lateral. Now the total. Your total surface area is the lateral, so 1/2 perimeter times the slant height plus the area of that base on the bottom. So 1/2 times 28 times 12.5 plus, and then what do we get for the area of our base? 49. So when we multiply the 1/2 times 28 times 12.5, we got 175, and then add 49 to that, and you get 224 meters squared. All right, next one. Okay, this next one is a cylinder. So before we jump into that, let's go on up here and let's look at the formula for it. Okay, a cylinder. We have our lateral surface area is 2 pi RH, and all this is multiplied, okay? It's 2 times pi times r times h. R is the radius, okay? And h, again, is the height of the cylinder, okay? So h is the height of the cylinder. So that's the lateral. And then for total, okay, we have the lateral part, 2 pi RH, plus 2 pi r squared. If you notice here, this pi r squared, that's the area of a circle. And on a cylinder, how many circles are there? 2. So that's where we get that formula from. So let's go on here. Okay, so we need r and h. Those are the only 2 things you need for a cylinder, the radius and the height. Careful here. You see this line goes all the way across? That means that this 24 is our diameter. Your radius is the diameter divided by 2. So if you see the line go all the way across, you have to divide it by 2. So 24 divided by 2, so it's 12. So our radius is 12, and then from our drawing we can see the height, the distance between the two circles, is 8. So now let me switch pin colors so we can see a little bit better. Okay, the lateral surface area. Okay, let's look at our formula chart. And you can always reference your formula chart. It's 2 pi RH. So 2 pi RH. So 2 times pi, and I'm using the calculator's value of pi, times my radius, which is 12, times the height, which is 8. So let me get this in the calculator, sorry. So 2 times pi times my radius, which is 12, times 8. So I get 603.18. Okay, I'm going to look at that, and it wants me to round to the nearest tenth, okay? So always pay attention. See up here? It says round to the nearest tenth. So this is going to be 603.2 because that 8 makes the 1 go up. And that's miles squared. Again, on the quiz, you only need just the number part. And then now the total. Your total is the lateral, so 2 pi r h plus, and now we have to do the circle on top and the circle on bottom. So 2, and then the area of a circle is pi r squared. So this first part we already know from here, so this is 603.2 plus, and then 2 times pi times, and then the radius is 12, so we square it. So 2 times pi times 12 squared, that's 603.2 plus, and then now here it's 904.77, so it's going to be 904.8, and now I'm going to add those two together. So 904.8 plus 603.2, and we get 1,508 miles squared. Okay, so there's that. Alright, next one. So now the next two shapes we have are a cone and a sphere. So again, we're going to go back to our formula chart. And we're going to look at the cone formula. Alright, the cone formula, it's pi RL for the lateral, and then pi RL plus pi R squared for the total. Again, L is slant height. Okay, cones and pyramids are kind of similar. R is still the radius. So let's go. So for a cone, lateral. Okay, and this one again, it says we want the lateral and the surface area, and it says round your answers to the nearest tenth. Okay, so lateral is pi r l. So the only two things we need from this cone are the radius and L, the slant height. Right away, L, the slant height, 22.4. Got that. Radius, well again, look, they give us the whole thing here, so we have to divide that by 2. Remember, the radius is the diameter divided by 2. So 20 divided by 2. So it's 10. So our radius is 10. So let's plug in. Lateral, pi times our radius of 10 times our slant height of 22.4. So just plug that in the calculator. Pi times 10 times 22.4, and we get 703.71, so it's just 703.7. That would be feet squared. And for lateral on a cone, it's only this like wrapping part. Okay, that's the only part of the lateral, just all the way around. So like on an ice cream cone, the part that you hold, you're like holding onto the lateral surface of the cone. Now, total is all this around the outside there plus this circle. So that's why for the total, we just do pi r l plus, and then the area of a circle, pi r squared. So we have pi times 10 times 22.4 plus pi times, and then our radius is 10, so 10 squared. So we know the first part here is 703.7 plus, and then 10 squared times pi. It's 314.15. So 703.7. 314.15 is going to be 314.2. So now we just add these together. 703.7. And we get 1017.9 feet squared. So there you go. So that's for a cone. Okay, now a sphere. Let's go back over here. For a sphere, well, a sphere, there's no lateral surface area on a sphere because there's no flat sides on it, okay? There's only like the outside of the sphere. There's no edges or anything to it. So for a sphere, you can only do total surface area, and it's 4 pi r squared. So for a sphere, total is your only option, 4 pi r squared. So the only thing you need for this formula is r. Okay, and r is the radius, so it is 9 in this case. So 4 times pi times 9 squared. So let's put that in the calculator. 4 times pi times 9 squared. Enter. We get 1017.87. Okay, so what's that going to round to? 1017.9, and it's miles squared. Kind of coincidence, we got the same answer. Alright, so there we go. So that's the basic ones here. Now the next ones I'm going to show you, they're just kind of to remind you, because sometimes you will have to leave your answer in terms of pi. Okay, and that would only be for cones, cylinders, and spheres. So this one, it says find the surface area. So this one, they only want the total. So total surface area. So for a cone, the total surface area is pi RL plus pi r squared. Okay, and guys, I've been working with these formulas for a long time, so I have them kind of memorized a little bit, but when I have to come back to them, I always look at my formula chart. So if you don't have it memorized, print out that formula chart or just keep that formula chart handy when you're doing your quiz or your practice. It's nothing to it. So pi RL. Okay, only thing I need from this cone is the radius and L, the slant height. So L is this 24.6. Got that right away. Radius, just do 22 divided by 2 because they give us the whole diameter. So 22 divided by 2, so it's 11. And just make note, you know, if the line goes all the way across, divide by 2. If it goes only halfway, like here in our cylinder, you've already got the radius. You don't have to divide by 2. Just remember that distinction. So let's plug in. Pi times 11 times 24.6 plus pi times 11 squared. Alright, now I calculate these two things separately and then I add them at the end. So, and you see we have to leave our answer in terms of pi. So when I do that, I'm only putting in these numbers except for pi into the calculator. So I'm going to do 11 times 24.6. So I will get 270.6, and then I'm going to put pi after that, okay, plus, and then now over here, I'm not putting pi in the calculator, I'm just putting the 11 squared, and so 11 squared is 121, so it's 121 pi, and then now to add these, you just add the numbers in front. So it's kind of, you can think of pi kind of like x, okay, so just add 270.6 plus 121. And so we get 391.6 6.6 pi, and it's feet squared. So that's for our cone. Okay, cylinder, we want the total, okay, for our cylinder. Let me change pins here. So total is 2 pi RH plus 2 pi r squared. So r, the radius, is 6, and h, how tall our cylinder is 9. So go on ahead, we'll plug this in. 2 times pi times 6 times 9 plus 2 times pi times 6 squared. So here I'm going to plug in everything except for pi. So I'm doing 2 times 6 times 9, and then pi will be at the end. And over here I'm going to do 2 times 6 squared, and then pi will be at the end there. So 2 times 6 times 9. So this is 108 pi. And then 2 times 6 squared, that's 72. And again, just put your pi. And so now add them together. 72 plus 108 is 180, 180 pi. And that would be feet squared. So there you go. That would be your total surface area for the cylinder in terms of pi. And then our last one. Here they didn't give us a picture, but they told us it's a sphere and has a diameter of 22 feet. Remember, for a sphere, it's 4 pi r squared. Okay, 4 pi r squared. So all we need is the radius. So if they tell you the diameter, you have to divide by 2. So do 22 divided by 2, and so it is 11. So do 4 pi times 11 squared. So I'll do 4 times 11 squared, and then just put pi at the end. So 4 times 11 squared. So it's 484 pi, and it says feet, so feet squared. Alright, so we've just covered, just so far, basic surface area, nothing fancy. So what we're going to do now is go on to a little bit more complicated things. So the first one here, it says find the lateral area of each figure, and it says round your answers to the nearest tenth if necessary. Okay, so we have a hexagonal pyramid in this one and a pentagonal pyramid. Now we're only finding the lateral surface area. So we have a hexagonal pyramid, and of course I'm not going to draw a very good one here. So we have a hexagon. Okay, and then imagine that we had from the hexagon all the sides coming up here. Okay, so basically it's a pyramid with a hexagon as its base. Alright, now we're only finding the lateral surface area, which is just the area of all these 6 triangles, because it's a hexagon. Okay, so for a pyramid, alright, let's go back. Let's go back a little bit. Alright, for a pyramid, for the lateral surface area of a pyramid, it's 1/2 the perimeter of the base times L, the slant height. So you just have to know how many sides a hexagon has. A hexagon has 6 sides. Okay, and they're all going to be, it says a regular base, so that means all sides of the pyramid, the base of it, are going to be the same length. So we have a hexagon. Okay, and it says a regular base with each of them measuring 7 kilometers. Okay. So how do we find the perimeter of a hexagon? Well, there's 6 sides, and in this case there are 7 of them. So you multiply it by the length. So it's the number of sides times the length of each side. So 42. And again, you could do that by adding up all the sides. Okay, so the perimeter of the base is 7, and then slant height, well, we read the description here, a hexagonal pyramid with a slant height of 13.4 kilometers. Okay, so 13.4. Okay, and then the regular base measuring 7 kilometers on each side. All right, so lateral, it's 1/2 the perimeter of the base times the slant height. Okay, and the whole reason why it's 1/2 is because these sides here, they're all triangles. And well, how do you find the area of a triangle? Base times height divided by 2. So that's where that 1/2 comes from. And then the perimeter is all of these sides. Okay, so basically there's 6 triangles, right? And they're each going to have a base of 7. And then L, the slant height, is the height of your triangle. So that's why it's 1/2 P times L. So 1/2 times 42, that's the perimeter, and then times our height here, which is, our slant height is 13.4. So we will just type that into our calculator. So 1/2 times 42 times 13.4, and so we will get 281.4, and it would be kilometers squared. And again, on your quiz, you don't have to put in the units. It's just the numbers. All right, next thing, a pentagonal pyramid. Okay, so a pentagon. Our base is a pentagon. How many sides does a pentagon have? 5. All right, so the perimeter of our base, there's 5 sides, and we're only going to do regular pyramids here. Okay, regular hexagons, regular pentagons, just regular pyramids. So whatever your side length is, just multiply by the number of sides. So 5 sides, and what does it say? Slant height is 13, so L is 13, and then a regular base measuring 12 yards on each side. So there's 5 sides because it's a pentagon. Each side is 12, and 5 times 12 is 60. And now for the lateral area of a pyramid, it's 1/2 perimeter of the base times the slant height. So 1/2 times 60 times, and then our slant height is 13. So 1/2 times 60 times 13. And so we get 390. And that would be yards squared. All right, so that's for if you have a regular pyramid that's like a pentagon or a hexagon. Okay, it's just like it's got a regular polygon as its base. So anytime you see like a regular polygon as the base of a pyramid, just follow this formula, if you will. All right, next thing that we have is here, let's read these 2 ones. It says, solve the following and round to the nearest tenth when necessary. It says the lateral area of a cone is 60 pi meters squared. The slant height is 15 meters. What is the radius? Okay, so they're giving us the lateral, and then we're needing to get to the radius. Okay, we need to think about this. It's a cone. Okay, so let's look back at our formula chart, or look back at one of our other problems here. Okay, look at this, a cone. The lateral surface area of a cone is pi times r times L. So lateral, pi times r times L. And we want to get only down to the radius. Okay, so we got to look here. It says the lateral area of a cone. So pi times r times L. When you do that, you get out 60 pi meters squared. Okay, I'm not going to write the units because I'm not worried about them right now. So I know that if I take pi times the radius times the slant height, I will get 60 pi. Okay, and then you tell us the slant height is 15. So let's plug that in over here. So I have pi times r times 15 is equal to 60 pi. Okay, y'all, all this is like solving a regular equation for x, except this time we're solving it for r. Okay, a thing that we can notice here, do you notice how they both have a factor of pi on both sides? That means we're multiplying pi on both sides. Those can cancel. So I have r times 15 is equal to 60. So basically I say, okay, how do I get the r by itself? Well, divide by 15. So 60 divide by 15 and it will give you 4. So our radius is 4, and that would be meters. Okay, so when you have these ones, it's just about working backwards. Okay, now here it says the surface area of a cone is 55 pi centimeters squared. Okay, so surface area of a cone. Remember, it's pi times r times L. That's the lateral. And then on a cone, we just have the one circle, so it's pi r squared. Okay, and they tell us that that's 55 pi. Okay, and then they say the radius is 5, and what is the slant height? Okay, I'm going to go and plug in here, 5 for my radius. So pi times, and then radius is 5, times L, plus pi times 25, because 5 squared is 25. Okay, now the way I'm going to show you how to solve this is not the only way to do it. Okay, I'm just showing you guys this because I think this skill will be very helpful for you as you go further on in your math career. Okay, I'm going to factor out a pi. Now, it's not complicated, guys. Just see here, look. Do you see how I have a pi in this term over here and a pi in that term? And there's also a pi over there on the other side. I notice that each term, and remember, terms are separated by plus signs and minus signs. Each term has a pi in it. That means I can bring them out. So over here on the left side, I have pi. I'm going to put parentheses. 5 times L plus 25. And over there, it's still 55 pi. Okay? I'm noticing this because it's going to make my division a lot easier. Basically, what I've done here on the left-hand side is just the inverse, the opposite of the distributive property. So instead of multiplying pi into everything, I've brought it out, okay? So if you multiplied this pi back in here, you'd still end up with the same thing. All right, so essentially I'm just saying I have pi over here, pi over there. Guess what? They can cancel. You're gonna love it when things cancel. So now I have 5 times L plus 25, and that's equal to 55. Well, I need to solve for L. First thing I need to do, it's a two-step equation, y'all. Take away 25 from both sides. So 55 minus 25. 5L is 30, because 55 minus 25 is 30. Okay. Just now divide. Okay, divide by 5. So the slant height is 6. And what are the units? Centimeters. All right, there you go. So that's for if you're having to work formulas backwards. So they give you the lateral, or they give you the surface area, and they want you to get out one of the variables that you'd normally plug in. Okay. Now, these two problems are our last kind of surface area problems that you will have. Okay, and it's composite surface area. You have to be a little bit careful with these because just like when we did the area of circles, or that the 1 week that we did circles where we had like, it was a shape that looked like this with a sector, okay, and we had to make sure we didn't double count that little triangle there where they both overlapped. Same thing here. Okay, basically what you want to do is divide your shapes up into two shapes. Okay, for number 14 here, problem 14, I have a cone on top. Now on the cone, I only want the stuff that, like, if this was an actual building, you know, or like a, I don't want to say building, okay, if this was like a toy, a children's toy, okay, if this was a children's toy, I only want the area of the surfaces where I could touch on the outside. So for a cone, it would only be this round, the lateral area part here, okay? It would only be the lateral area part. I could not, if this was a solid toy, I could not touch this part right here, this circle. Okay, so when I'm taking into account my surface area calculations, I do not want to double count this circle here in the middle. Okay, I don't want to count it at all in either the cone or the cylinder because they cannot, like, it's solid. Those two things are fused together, if that makes sense. So for this one here, I just want the lateral of the cone, okay? And then now on the cylinder, I also only want the lateral of the cylinder, so the, you know, the tall side here, okay? Lateral of the cylinder. And then on the cylinder, I only want the one base on the bottom, okay? So basically, like, if this was a toy, all the parts that would be exposed to the air if you just like held it up, okay? Those are the pieces that you want to add together. So plus one base of the cylinder. So now we'll go through and we'll actually calculate that. So before you start these problems, I want you to think, okay, from the cone. I can see it's a cone on top. Okay, what part do I want of it? Do I want the lateral or do I want the total of it? Well, in this case, we only want the lateral because that's what's sticking out. So I'm going to do lateral of the cone. It's pi r L. So pi times, and then the radius. The good thing about this is that the base of the cone and the base of the cylinder, they're the same. They're that circle, okay? So the radius here is the radius at the top as well. So my radius is 6, and then the slant height for my cone is 7. Okay, and here notice they say round your answers to the nearest tenth. So we're going to put pi into the calculator. So we're doing pi times 6 times 7. So we want 131 point, and then it's 94, so it's just 131.9. So that's the lateral for the cone. Now the lateral for the cylinder, okay, that's 2 pi r h. And again, I've got these kind of in my head. If you need to look them up, they're all on that formula chart. Okay, so lateral of the cylinder. So 2 times pi times, and then my radius is 6, and then times the height, 8. So 2 times pi times 6 times 8. It's 301.59, so it's going to be 301.6. Okay, and then the base of the cylinder, remember the base for your cylinder is a circle. That's why it's called a cylinder, because it's got a circular base, and there's 2 of them. It's just pi r squared. So pi times 6 squared. And so that's 113 point, and it's 0.9, so it's 0.1. Okay, and so now for that total surface area, we're going to take those 3 numbers and we're going to add them together. So we have the 131.9 plus the 301.6 plus the 113.1. So 113.1 plus 301.6 plus 131.9. And so we will get 546.6 millimeters squared. And that would be our total surface area for this cone sitting on top of the cylinder. All right, now the next kind of I guess, popular composite figure here is a pyramid sitting on top of a rectangular prism. Okay, so the pyramid, let's look first here. This rectangular prism, I notice the base, okay, and the base is, you can tell it's the base because it's sandwiched between where the pyramid and the rectangular prism are. That's what you have to use as your base, okay? So I notice it's 8 by 8. So my base is a square, all right? So this is a square pyramid up here. Now, again, think about it. For the pyramid, do I want the total surface area or do I just want the lateral? I only want the lateral. So with the lateral of the pyramid, okay, and then now let's talk about the rectangular prism. I want the area of this base on the bottom, okay, so I want one base. And then I also want the lateral, okay, these four sides. So it's like kind of like a house. You want the four walls and then the four sides of the roof, and then we want the bottom of it, okay? So plus the lateral of the prism. Okay, so let's go through here. Lateral of the pyramid. It's 1/2 times the perimeter of the base times the slant height. Okay, so let's calculate here. Perimeter of our base. This is the base of the pyramid, which is also the base of the prism. Okay, it's a square. And it's got sides that are each 8. So our perimeter, well, what's 8 times 4? It's 32. So the perimeter of our base is 32, so 1/2 times 32. And then our slant height, I know it's kind of confusing on this picture, but this 6 meters here, it's like the height of this pyramid. I'm sorry, well, it's the slant height of this pyramid. It's the height of this triangular face right here that I'm tracing. So my slant height is 6, so times 6. So 1/2 times 32 times 6. So it is 96. So that's the lateral surface area of the pyramid. Okay, now we want the lateral of the prism. Okay, lateral of the prism. Again, it's perimeter of the base times the height of the prism. Okay, the height of the prism is the distance between the bottom of that prism up to where it's meeting the pyramid. So right there. So at 5. So again, our perimeter, it's the same base. So our perimeter is still 32. And then the height of the prism is 5. So 32 times 5. So it's 160. Okay. And then now we want the area of the base. Okay, remember the base is the base of the prism is down here on the bottom. It's that square. So this would be big B. Okay. And it's base times height, and that's only of the shape that the base is. So for this is a square, so base and our height, they're both the same. So it's 8 times 8. So 64. All right, and then now what we need to do is just add these together, and that will give us the total surface area for this combined shape. So you have 96 plus 160 plus 64. Okay, and we get 320. So it's 320 meters squared. All right, so there you go, guys. That's basic surface area working backwards with surface area, and then also doing composite surface area. And again, if you have any questions, reach out to me or your teacher, let us know, and we'll be able to help you. See you guys next time.